So let's talk about continuous unit testing and testing in general for our database code. Now in a previous module, we've talked briefly on testing and we listed some types, but we want to look at a little more detail. The different types of tests we can run, when and where we'll run them, and how they might apply to our application and database code to ensure our software is of a high quality. There are different types of tests we perform, but we perform these different types of tests in different environments. For example, for our developers, we may do unit testing and static analysis or naming standard testing in our development environment on the developer's laptop. And those are appropriate. They're fast, they're quick, and we let those run. Now in continuous integration, we might repeat those same tests because we don't want to depend on the developer to run them. We want to ensure they run every time. And one thing we know about humans is that we're frail and fragile and we forget about things. We have fallibilities in how we develop software. So we use continuous integration to ensure that all of the unit tests that need to run and all of the standards-based tests will run on the commits. Whether developers ran them or not, we'll ensure that they run again. But we may add additional testing. We may add functional testing that tests multiple modules together to ensure that the whole system works when we're testing functionality. For example, I may have a stored procedure that calls a function and then queries a table. In a unit test world, I want to test each one of those items separately and not have any dependencies. But in a functional test, I may test all of those together to make sure they work. When I go to QA, I may do different testing. Now QA should be active and proactive, as we said. They should be talking to development and operations to understand the requirements and needs of both. So they may do larger scale behavioral testing. Does the system work as a user might expect it to work? They may perform security testing. Do we have any vulnerabilities? Can users perform more actions than they should be able to? And they may do performance testing as well. Larger scale testing on larger data sets to ensure that when we get to production, our code will perform as we expect and our application will work. Then of course, we test in production as well. That's the complete test. That's the one that really counts. That's where we do performance testing for sure, and that's where our customers test our software. Production is the worst place to find bugs. So typically we want to do as much testing as we can before we get to production because we want to ensure that our customers have the best experience possible. And in a DevOps world, certainly we understand we'll make mistakes. Our customers will find bugs in production. We want to feed that back and ensure that we are catching those bugs earlier on. No matter what kind of testing we're performing, we're constantly going to enhance it and change it over time. Now let's look at some of the individual tests. We'll start with static analysis and standards tests. We found over decades that one of the things that really can help prove code quality is to have some sort of static analysis take place and certainly some standards applied to testing. The standards typically make us more productive as developers because all our code looks very similar. And static analysis finds some of the simpler, easier errors that we might have. These topics, these tools, they're much more mature in the application world. In the database world, we don't have a lot of tests that will do this or a lot of tools that will help us do this. So we have to find ways to do this. Now, doesn't mean we can't do it, it just means we have to be creative. I do like to run these tests first because they are fail-fast tests. For example, one of the things I like to do is test for standards. We want objects named a certain way. We don't want random names generated by the platform themselves. So I test for these types of things using static analysis and fail quickly if they don't pass because these are typically very quick tests to run and they're very simple things. And we want developers to build these habits of getting better in how they rate their code. So if we fail in these quick tests, they learn very quickly. Other things I might test for in standards is ensuring something like a primary key or foreign key always exists and always named. I might ensure that their constraints always exist between certain columns or tables. And I might do static analysis like avoiding code smells. For example, I want to avoid no lock. I don't want to use select star. There's various database coding techniques that are problematic. And so I want to write tests to ensure that I can do this. As I mentioned, we don't have a lot of tools. In the SQL Server world, SQLite and SQL Code Guard are two commercial offerings that allow us to do things. SQL Cop is an open source project that lets me write standard-based tests. Those are the type of items that I like to use, and we'll give you some examples in the lab so that you can try those out as well. Now, one thing about all of these tests is that I typically have fairly hard rules for these tests, but there are always exceptions. For example, every table should have a primary key. Every table, always, 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 until there's a reason not to have one. And in those cases, I don't want the test to constantly fail. I don't want brittle tests that are built for one table or two tables. Instead, what I need to do is add an exception. If I have a table that really doesn't need a primary key and the developer can justify that, I want to make sure I can add an exception to the test. It's one of the issues with our database objects is that we often find exceptions because we're trying to meet some particular requirement. So all my testing needs to have exceptions as well. Let's move on to unit tests. Now, unit tests are designed with the idea that I'm testing the smallest bit of functionality I can. Does this one function work correctly? Does this one table structured correctly? Does it have the proper default? Does it have a constraint on it? I'm trying to just test a very single unit of work or a single unit of code at one time. Now, they're important. They're a low level of test. They typically run fast as well. But they also allow me to start testing that my code is actually meeting the requirements for my particular application. Now, for tables and views, we often test that I've got referential integrity or that the metadata is set a certain way or I've built those constraints, and that's fine. We typically want to put some sort of test on there because our tables and views are essentially part of our API. Lots of application code, lots of other users will query these, so I want to make sure that I've tested them appropriately and I know when they change. For my other objects, my code objects like store procedures, views, functions, I want to write tests that look for certain conditions that may cause me issues. For example, boundary conditions. What happens when I cross a boundary? If I've got sales data and I offer a discount at 5%, what happens at 4.9%? What happens at 5%? What happens at 5.1? I want to have these different values. Certainly want to test edge case values if I do negatives for numbers, if I do dates that are quite far distant in the future or past, if I have empty strings, I want to catch all those boundaries. Null values. Nulls are a concept in computer science that a little strange, a little hard to deal with at times, but nulls in databases sometimes cause problems in applications. So we want to test what happens with nulls. What happens if I've missed parameters, if I have application code that works across different versions. I want to make sure that the old version with 3 parameters and the new version with 4 parameters, both of those work. 0-1 sum is a heuristic that we want to test for often. What happens if no rows are returned, if one row is returned, if multiple rows are returned. Those are the types of unit tests that we want to build, and we'll give you some examples in the lab. Any type of test you can think of that covers an issue, especially an issue reported by a customer, I want to ensure gets incorporated into my CI process and it's run in the future. But I don't want to stop with static code analysis and unit tests. I want to do other tests as well. I certainly want to have more comprehensive tests. I may not run these as part of the CI process on every commit, but I do want to run them at some point in my process before I deploy my software. Our application is going to be used by users. It's going to be used by multiple people, multiple applications. So I want to test different things. I want to test security and ensure that do I have minimal rights assigned. That's an important one. These days, security is a bigger and bigger issue in software. So we want to make sure that we're not granting unnecessary rights and we're not opening ourselves to database code vulnerabilities such as SQL injection. So I want to have those tests available. And often these are the types of tests that QA will help us with or operations will help us with because they'll discover issues as we deploy the code to bigger and bigger environments, more environments in the intermediate stage, and we use larger data sets. I certainly want to make sure as well that my information and metadata is protected and I'm not disclosing anything. Performance is always a big issue with databases. We constantly find that code works great in development, performs very poorly in production. Often this is because the data set is so large and so different that the system behaves differently. Our query engines and query optimizers actually have tipping points where they choose different methods of executing queries or performing work based on data size. So we want to have performance testing that works on large data sets. Typically, we want to go to production-sized data sets, which may be a refresh of production, but I often recommend going for larger than production data sets. Nobody in the world has a database that's shrinking. If I test today on production data, by the time I deploy next week, I may have 5% more data. So I typically want to test 1.2 to 1.5 times the size of production data so that I'm sure my code will work well. I also want to provide a workload against this performance test that simulates what we see in production. Operations usually understands what that is, so that's the case where operations and QA and development have to work together to ensure that the code that's being deployed is adequately tested and we know how to write those tests to make that work. And we also want to make sure that we get those behavioral and functional tests done that cover the entire system. Look at the entire workflow from a user standpoint, that they are trying to accomplish a certain piece of work exercise a certain functionality, we want to make sure we test that entire thing. We may have unit tests for each piece, but do they work well together? Those are the types of tests we have to run. And again, we want to run them in an automated fashion. In DevOps, we want to be repeatable and reliable. We want things to work the same way every time, so we want to automate all these tests. The last thing I want to talk about is that we have to often ensure we have test data for these tests. I know my code runs really fast if I don't put any data in the database. So I have to be sure that at different points in this process, I have the way to inject test data in the system. In other modules, we've talked about test data, but we want to make sure here that we actually inject test data that's relevant for that kind of test in the system. For unit tests, we may have data inside the test. For larger tests, we may have to inject that data separately. We'll have to do what works for us to ensure that the system is adequately tested. And the only way to find that out, you'll have to take some ideas, some thoughts, some information I give you, and try it in your environment. Test it to be sure it works.